But we're going to start off with a little intro activity. Okay, if you had 3 times 2 plus 8, do the mental math, what would you get as an answer? 30. Good. And how did you get 30? So you did 2 plus 8, you did order of operations, you did brackets first, you got 10. 10 times 3, you got 30. Okay? You went grocery shopping. And they had a special on, and you love, we've been like using apples and oranges all the time. They had bags. Here, I'm going to try and draw a bag. There's a bag. Inside that bag, there were 3 apples. Ooh, those look like apples? I don't know. Maybe a little twig on there. And 2 oranges. And it was like a great price. You could buy 1 bag for 3 apples and 2 oranges at a great price. So you bought 3 of these bags. What did you have in the end? What's your total that you had? You bought 3 of those bags, 3 times this bags. How many apples, how many oranges did you have in the total? You had 9 apples and 6 oranges. Does that make sense? Okay. All right. Now, don't want to scare you, but you guys are doing some complicated algebra here already, but you don't know it. But you're right. You would have 9 apples, and is that all right if I use an A for apple? And 6 oranges. Oranges are bad. Because if I use an O for oranges, doesn't that look like 60? What should I? 9 apples. What should we call them mandarins? Mandarin oranges. Then we can use 6 mandarins. And then it's still color coding. I'm still happy with that. Is that okay? Okay. Now, what you just did with your algebra is you said originally what was in 1 bag. I'm going to put it in brackets here. What was in that 1 bag? There was 3 apples and 2 mandarin oranges. I put it in brackets to represent it's in that bag. And then how many bags did we have? We had 3 of them. This is how it's written in algebra. And the answer is, in total, we had 9 apples and 6 mandarins. Now, in our original question, you could do things like add 2 plus 8, because order of operations, 2 and 8 are like terms. 2 plus 8 is 10, and then you did 3 times 10 to get 30. No problem. Here, 3a and 2m, they're not like terms. Just like 3 apples and 2 mandarin oranges aren't like fruit. You can't just put them together and say I have 5 appledrins, or whatever they would be. Okay? So the question is, if this was the algebra, how could we get from here to here without having to draw a bag of apples and oranges? 3 times 3 is 8 times 2. Okay, so Duncan's saying we could do 3 of those ones, right? Because we had 3 bags, so we'd have this 3 times. We would also have this 3 times. Does that make sense? Well, you could add them together and get 5, but they're not the same thing. And so that's the idea of algebra, is we don't add things that are the same. If someone says, what do you have? It's better to say I have 9 apples and 6 mandarins rather than I have 15 things. It's more descriptive if we can say exactly what we have in the end. So Duncan's saying, well, since we have 3 bags, we're just tripling the apples and tripling the mandarins. So I could just take this 3 and multiply it by that, and this 3 and multiply it by that. Would that have worked here? Could I do 3 times 2 and 3 times 8? What would I get if I did 3 times 2 and 3 times 8? 3 times 2 is 6. 3 times 8? 24. Does that still equal 30? Yeah. Of course, we never do this, do we? We always do order of operations. We do the brackets first, and then we multiply. But it's interesting to know that you could have just tripled the 2, tripled the 8, and added them together to get 30. But when we have something inside that doesn't match, we can't add these together. So we can't do the order of the operations the same as we used to. Okay? All right, you're going to go to the grocery store again. They have a new special on. Here's the bag. What are you buying? Oh, you guys. Okay, we've got, yeah, the spicy Cheetos. So we're going to have, how am I going to draw those Cheetos there? Are they in a red bag? You get 3 bags of the spicy Cheetos. Okay. What else do you guys bring to class? Oh, Kool-Aids. 4 Kool-Aids are in this. Okay. And Skittles? 1 Skittle. Okay. You can buy 3 bags of Cheetos, 4 Kool-Aids, and 1 Skittle for $5. Good deal? Okay, good deal. Very good deal. So Cherish likes that deal because she's always bringing the Cheetos to class. So she's like, I'm going to buy 5 of these bags. How many of each would she have? Okay. In algebra, we would show this as 5 times, and in the one bag, we have 3 Cheetos, 4 Kool-Aids, and 1 Skittle. That's how we would show it in algebra. Okay? But if you bought 5 of those bags, what would she have in the end? How many Cheeto bags would she have? 15. 15C. How many Kool-Aids would she have? 20 of them. And how many Skittles? 5. Okay? And what you're basically doing is saying, if I have 5 of this, the bracket's kind of like the bag. If I have 5 of that, well, I have to multiply the 5 times this, the 5 times this, and the 5 times this. And we're going to learn that in algebra, we're going to use those arrows to sort of show our work. To say that if I had 5 of these, well, I have this 5 times, I have this 5 times, I have this 5 times. And that all will work out to this as an answer. Okay? Now, often when students learn, and this is our notes, the distributive property, and they learn it as an algebra rule, it's just sort of like, well, this rule doesn't make sense to me, and then you forget it. Okay? But if you can now think of the bracket sort of as a bag holding something, the number out front, how many bags that you're buying, what we're asked to do when we expand it is say, well, what do you have in total? Okay? So the word expand in math means you want to have no brackets in the end. You want to find out what you have in total. If you took everything out of the bag and spread it out on the floor. Right? One bag has an x squared and a minus 5. And you have 3 of them. So the distributive property says that we multiply each term inside by the term on the outside. So can you see that if you multiply this, you would have 3x squareds in the end. And if you had minus 5 3 times, that would give you minus 15. This is the idea. And the wonderful thing, in my opinion, about math, oh look, a Kool-Aid. What are the chances of that? These are actually recyclable. That It's all connected to stuff you've already done. The trouble with algebra is often you don't realize that connection and you try to learn it as some weird thing that you've never done before. And if you learn it that way, it makes it very difficult. But if you can connect it to things you already know, then it can become easier. Sometimes there's just a negative outside. And we've done this already when we subtracted. I don't know if you remember that when we subtracted something in brackets, I said, hey, you want that negative to go to each one. And when we distribute that, that'll be negative 3x. A negative times a negative will be plus 5. And we called this earlier the additive inverse. Okay, here's one for you to try. Okay, I would suggest every time to show your work, you draw the arrows to remind yourself that that negative 4 is getting multiplied by each of them. Then how do we multiply? Multiply our numbers. Negative 4 times 5 will be negative 20x. And the negative 4 times negative 2 will be positive 8y. And a negative times a positive will be negative 24. So the word expand means you want to get rid of the brackets. In order to get rid of the bag or the brackets, you need to pull everything out and count it up and see how many you have. And this would be the answer. This next one says expand and simplify. Okay? Simplify means that we want to have everything that's alike put together. So this is sort of like we've got a bag special with Cheetos and Kool-Aid and Skittles again. Someone buys 3 of them. Someone takes it out, rearranges the bags, and now they put only 1 Cheetos in that one. They add another 2 Kool-Aids and subtract 4 Skittles. And then this minus 2 probably means that somebody ate a bunch of stuff. So we start off the same way and then saying if I have 3 of this bag or this set of brackets, that 3 would go to all of those. And if I ate 2 of the bags, I'd eat 2 of those, I'd eat 2 of those, and I'd eat 2 of those. So we start by distributing in both of them. And we're going to write out, can you see that you're going to write out 6 things in the end? Because there's 3 green arrows, 3 things there, 3 blue arrows, 3 there. We're going to have 6 in total. So the first one, 3 times 2x squared. We'd have, oh, I'm going to color code this. Those are green arrows. I'll write it in green. 6x squared. 3 times the negative 3. Negative 9. And 3 times 5. Plus 15. Now I'm going to go to my blue arrows. A negative 2 times an x squared. Negative 2x squared. A negative 2 times a positive 2. Negative 4x. And a negative 2 times a negative 4 plus 8. We have 6 things. We've done the expand part where we got rid of the brackets. But this question says expand and simplify. So we have to ask ourselves, is there anything alike with 6x squared? 2x squared, right? And this is like the Cheetos bag and the Cheetos bag. Someone bought 6 of them, someone ate 2 of them. What about negative 9x? Negative 4x. So again, I'm changing it colors because it's really easy to see like terms with colors, but if you don't have different colors, I also changed it to squiggle lines underneath so that I'm remembering those ones are alike. And lastly, plus 15. Is there anything alike with the plus 15? Plus 8. So now we can write our final answer. If you have 6x squareds minus 2x squareds, how many of them would you have in the end? 4x squareds. If you have a negative 9x and you subtract 4x, think of your number line. You're at minus 9, and you're going back 4 more. Negative 13x. And 15 plus 8. 15 plus 8. 23. Hey, when you do 15 plus 8, do you ever say, oh, 15 plus 5 is easy, that makes 20, and then I'd still have to add 3 more if I was adding 8? Do you use that as your mental math strategy? So here we've now expanded it and we've simplified it because we've put our like terms together. Okay. Yes. So now, in your notes, we have to double check this because the numbers were wrong last time. It says page 95. So before we get started on that homework, maybe. Okay, so 95 you can stroke out at the end of your homework there because it actually doesn't make sense. And your actual homework so 6 and 7, 12 and 13.